This is Algebra lesson 7.3b, right? We're doing it for a second day. Okay, scientific notation. We now know how it basically works. Now we're going to deal with multiplying and dividing using scientific notation. Okay, it's that simple. So, first thing we do is this. Let me take this for you here. Let me do a simple one here. Where is the sample? Okay, here we go. Here's the sample. 3.5 times 10 to the negative third. Big number or little number? Little number, right? Way less than 1, right? So there's that. And I'm going to multiply that by 7 times 10 to the fifth. So just watch. I'm going to show you how to do this. I think I may have shown you an example last year when we did this, but you didn't do it. So here's the deal. Last year I think we just did the A part of this assignment. Now we're doing the B. We're multiplying them. Here's the deal. Do you agree that we have 4 terms here? I mean, like I have this guy here. There's 3.5, and then there's 10 to the negative third, and there's 7, and there's 10 to the fifth, right? And all of them are being multiplied. Do you agree that they're all? I mean, it's just 4 multiplication things here. They're all being multiplied. These two guys, these things here are being multiplied. So can I move things around? Can I multiply what I want to? Yeah. I can. Do you agree? Okay. So here's the deal. Pay attention. Here's the deal. Here's the deal. You're allowed to multiply whatever I want to. Let's take the whole numbers, or the actual numbers that are not exponentiated. Let's do 3.5 times 7. What is 3.5 times 7? 5, 3, 200. It's 24.5. And how do I know that that's true? Can't I do some estimating here really quick? Right? 3 times 7 is 21. 24 is close to that. Does that make sense? I mean, how long should estimating take? How long? 2 seconds, right? I mean, it should just be a very quick, am I in the neighborhood? Am I in the right ballpark? Hopefully you didn't, that took me less time than it would for me to actually pull out my calculator and type it in. It really did. So why do we use a calculator? What's the reason? Even then, it's to save time. Do you agree? I mean, it's to save time. But if you can do something, if I said 2 times 2, do you need to type in 2 times 2 on the calculator? No, you know that because you have that memorized. That saves time. Whatever saves the most time, that's what you want to do. Anyway, so it's 24.5. So, okay, I'm going to write that down. 24.5. These guys are done. And now I'm going to go 10 to the negative third times 10 to the fifth. Here's the deal. Let's look at this. What is 10 to the negative third? How do I write that out? What's another way of writing that out without the negative? What is 3 to the negative fourth? How do I write that? What does the negative exponent mean again, people? I'm sorry, I can't believe it. It's less than 1, but what does it mean? We've had this. Do we need to go over that lesson again? I guess we do. Hold on. X to the negative third is the same thing as 1 over what? X to the third. Agreed? Do you remember this now? That those are the same thing? A negative exponent is simply 1 over that thing to a positive exponent. So, I will ask you again. What is 10 to the negative third? What's another way of writing that without the negative exponent? 1 over 10 to the third. Agreed? Okay. And can't I multiply that with 10 to the fifth, which is 10 times 10 to the fifth over 1? Okay. So then isn't it 10 to the fifth over 10 to the third? Right? Isn't that what that is? Okay, so then when I reduce everything, what do I have left? 10 squared on the top. So it's 10 squared. So it's 24.5 times 10 squared. I'm going to erase all this stuff. Now look at this. 24.5 times 10 squared. Is this scientific notation? No. Why not? It's not between 1 and 10. It's 24. So then, what do I need to do here? Here's the deal. What can I do with that guy to make it be in scientific notation? I need to move the decimal to the left one. So look here. Notice this. What I'm going to do is this. I'm going to divide this thing here by 10. I'm going to move the decimal to the left by 10. Now listen, this is the answer. That is the answer. It's just not written in scientific notation. Does that make sense? Does that make sense? Listen, if I have a total of 10 marbles in my pocket, but I have 6 marbles in this pocket and 4 marbles in this pocket, for me to have the same number of marbles, but if I want to have an equal number of marbles, I have to take 1 out of here, minus 1 here, and add 1 over here. Does that make sense? What I need to do here is I'm going to divide this by 10 as long as I multiply this by 10. As long as I multiply that by 10. Does that make sense? I'm going to shift 1, divide by 10, and move the other, multiply by 10. Because this, just even the way it sits, that's the right answer. I just got to make it scientific notation. So I'm going to move this to the left one, make this 2.45. Since I moved that decimal to the left, that means I made that number smaller. I now need to make this number bigger. So instead of 10 to the second, it would be 10 to the third times 10 to the third. Now it's in scientific notation. Does that make sense? That was the long way of doing that. Okay, that was the long way of doing that. We're going to do that exact same question now the short way. Okay. Nothing changes here. 3.5 times 7. We still do that. 3.5 times 7 is still 24.5. We can't get away from that. 24.5. That one has to be done. Now, though, when I have 10 to the negative third times 10 to the fifth, what am I allowed to do with those two things, right? What can I do? We know the answer is going to end up being positive 2, so then what can I do with them? Listen, I have a question. What if I have x to the 5th times x to the 7th? What does that end up being? Think before you say anything. What does that end up being? X to the 12th. So what did I do with these two guys? I added them, right? So 10 to the negative third and the 5th. What do I do with them? I add them. What's negative 3 plus 5? Oh, times 10 to the second. Does that make sense? And now we're back to the same spot where, is that scientific notation? No, this is where you have to move, you have to adjust it to make it scientific notation. Make sense? Okay. You guys try one of them babies then. Let's do this. See if you can do it. 6.5 times 10 to the 12th times 8.7 times 10 to the negative 15th. Try that for me, please. You're watching. This is where you learn to either confirm that you know it or you have to learn how to do it. First thing I do, the numbers, right? 6.5 times 8.7. What's that come out to? 56 point what? Okay, 56.55. Good. They're gone. They're done. And now I have 10 to the 12th times 10 to the negative 15th. When I combine them, what's that? What is 10 to the 12th times 10 to the negative 15th? Times 10 to the, right? 12 plus negative 15 is 12 minus 15, negative 3. Am I done? Is that in scientific notation? No. What do I need to do with the decimal to make it be scientific notation? I need to move, so in other words, I need to make this thing smaller, right? I'll move to the left. So the answer is 5.655 times 10 to the, so I made this guy here smaller, or I've shifted it to the left. I need to shift that thing to the right. What is 1 to the right there? What is making that 10 bigger? What would that be? Notice this. I need you to notice this, that when I shifted this thing to the left, right, this thing shifts to the right. And you can think of it as a number line here, right? I mean, like when I shift this, if I had to move this thing to the right, then I would shift this thing to the left. It's just whatever it needs to be done. Does that make sense? Okay. How many of you got that right? Does it make sense, though? Are we learning? Makes sense? Okay. Try another one. Try. Okay, here we go. Try 1.95 times 10 to the negative 8th times 7.8 times 10 to the negative 2nd. And you're right, I would definitely use a calculator to multiply 1.95 times 7.8. Why not? That would take forever. All right, first thing we do is we multiply the numbers, right? What is 1.95 times 7.8? 15 point what? 15.21. They're gone. Times 10 to the, right? And we know it's going to be times 10 to the, now we got to figure, okay. What is 10 to the negative 8th times 10 to the negative 2nd? When you add them together, it ends up being 10 to the negative 10th. Okay, is this written? First of all, is this the answer? Yes. Is it written in scientific notation? No. How do I get it to go to scientific notation? I have to move this decimal to the left one. Since I moved that to the left one, I need to move this to the right one, which would make this 1.521 times 10 to the negative 9th. Make sense? How many of you got that right? Make sense? We're good? Okay. So everybody got that one. So you guys know how to do that then? Now we have to deal with dividing these babies. Dividing them. Okay. There's a couple of ways to do this, but let me show you this one. So we have 3.066 times 10 to the 8th over 7.3 times 10 to the 3rd. Now, why don't they put these in parentheses? It's already in parentheses, right? Anytime you have the whole denominator is in parentheses, the whole numerator, they're already there, right? Okay. So, here's what you do. You look at this. I mean, we've done this already, right? First of all, when I have this, if I have 8x squared over 4x to the 4x, how do I reduce this? What do we do? What do I reduce? You reduce what? The 8 and the 4 I reduce the whole numbers. That makes this a 2 and this is a 1. And then what do I do with the x's? I eliminate what I can, right? And so I go, oh, okay. Then that would leave me with 1x on the top. So the answer to this whole thing would be 2x. Do you agree? Do you see it? You all remember doing that? I mean, that's something we've done. Okay. Nothing changes just because things get ugly. Okay. This is ugly. What do I do here? Reduce what? Reduce the numbers, right? Reduce these babies. What is 3.066 divided by 7.3? What's it come out to? 0.42. 0.42 over 1. We can just for now, right? But whatever, it comes out to 0.42. And then when I have this, I can reduce those. When I reduce things, what does that leave me with? 10 to the 5th on the top. So times 10 to the 5th. Oh. Is that the right answer? Yes. Is it written in scientific notation? No. How do I get it to be scientific notation? I have to move the decimal to the right one. So I'm going to move the decimal here to the right one. Since I moved that to the right one, I need to move this to the left one. So then it would be 4.2 times 10 to the 4th. Does that make sense? Okay. What if I asked you to turn this into the real number? Do you remember how to do that? We just did that yesterday too, right? How do I turn that to the real number? That would be 4.2, and then I move the decimal place over to the right. Why the right? Because it's a big number, and I move it over 4 spaces. 1, 2, 3, 4. So then there's the new decimal. It would be 42,000. Does that make sense? So if I asked you to do that, okay. Try one. Try one. 2.3958 times 10 to the 3rd over 1.98 times 10 to the 8th. Just because it's ugly, nothing changes. Try and do this. You're good to go. I mean, I'll probably give you one other one, but, we'll see. All right, here we go. First thing we do is we look at this, and we go, what can I reduce? Right? How do you do 2.395? Aren't you glad I let you use a calculator? I mean, can you imagine if I didn't? I mean, that would be so messy. Divided by 1.98, what does that come out to? 1.21. Okay, times 10 to the, and then you go, okay, what is that? What is 10 to the 3rd over 10 to the 8th? That leaves me with 10 to the 5th on the bottom. So how do I write that in scientific notation, 10 to the 5th on the bottom? It's 10 to the... Is that written in scientific notation?
Yeah.
We're done. Right? We're done. How many of you got that? Yeah.
Could you explain like how you know what's on the bottom, what's on the top?
I won't do a 10. Hold on. We'll do this. X to the second over X to the fourth. Okay. X times X over X times X times X times X. Agreed? Where did they land? What's left? 2 X's. Where? Oh, okay. So if the bigger number's on the bottom, then that's where it lands on the bottom, right? And so then this would be 1 over X squared. How do you write that as without a fraction bar? How do you write that without the fraction bar? X to the negative 2. Right? Yes, Big John? Right. If there's a negative on the bottom, here, let's do this one. Here's a good one. They have you do this one right here. You ready? Here it is. Try it. First thing we do, what is 1.305 divided by 1.45? 0.9. And notice this, before I do anything else, I know that this is going to be written in scientific notation eventually, so what do I do now? What do I write down? Times 10 to the something. Okay, well, there's that. How do we do this? Do you remember? I have a negative exponent on the bottom. What's that mean I do with that thing? To the top, making it 10 to the... Does that make sense? Do you remember that now? Is this written in scientific notation? Move this thing to the right one. 9 times 10 to the... Since I move that to the right, this one gets moved to the... 9 times 10 to the 6th. How many of you got that? Does it make sense? Make sense? Does it not make sense? Awesome. I don't care that you got it, as long as it makes sense. Okay. Here's your homework. Let me make sure. Okay. All right. It is page 419 to 422, 20 through 53 even.